Hi guys, welcome to Insight Tuesdays, navigating the world of observability. Last Tuesday, we talked about observability and its pillars, and we also learned about logging and a tool called Splunk. We saw how you can use Splunk to um, uh, watch your logs and take out results from them. Now, today we have the second pillar of observability in our bucket list, that is metrics. So let's go on to our agenda for today, and then we'll talk about metrics. So number one is we'll know about what metrics are and its types. Then we'll talk about metric collectors and storage, which are essential for visualization and analysis. Then we'll talk about red metrics, which is another, a very versatile combination of metrics. Then we'll talk about a tool that is Grafana that helps us to visualize your metrics and take out results from them. And then we'll go on to the demo. We'll see what a dashboard on Grafana looks like, and we'll also run a few queries, and also we'll create our own dashboard. So let's get started. So in a definition, metrics are quantitative measurements or data points that provide insights into the performance, behavior, and health of a system. Metrics are specific, measurable values that represent different aspects of a system. These can include data related to resource utilization, response times, error rates, throughput, and other relevant parameters. In layman terms, it is like the symptoms, or what do you say? Some of the metric values or quantitative values about your body, like whenever you go for a health checkup and it shows what your health looks like and how healthy you are, like BMI and glucose level, temperature, etc. So there are three types of metrics. First is performance metrics. It reflects the efficiency and responsiveness of the system. Second is health metrics. It indicates the overall well-being and reliability of the system. And third are business metrics that connect system performance to business goals and objectives, because watching over those is also important. So you have the objective alignment with your users, and you can what do you say, you can also provide or deliver what was actually in the vision. Now, what are the benefits of metrics? Let's talk about that. As you can see, these are some of the many, like, it is understood benefits of metrics. Metrics enable the early detection of anomalies, deviations, or potential problem within a system, because by a number you can see how your containers or your cloud native architecture is performing. Also, it shows optimization efforts based on data, improving overall efficiency and user experience. It also helps in understand resource usage pattern over time, so you can scale or increase volume for better efficiency in your infrastructure. Now let's talk about metrics collector and metrics storage. These two with a combination gives you the visualization you see in a dashboard while you use a tool to analyze metrics. So first we'll know about these separately. Um, this is a very, this is a quote by Ken Moss. Metrics are like a compass. They help you guide in the right direction, and without any quantitative analysis. It is always said that you should focus on quality rather than quantity, but if you keep track of the quantity, you can increase your quality as well. So let's talk about metric collector. A metrics collector is a tool or component responsible for gathering and collecting data from various sources within a system. It is reflected in its name. Metrics collectors aggregate data from different sources, combining information to provide a holistic view of a system performance. Now, metrics collector often allow for configuration to specify which metrics to collect. so you don't collect unnecessary data or over analyze, or what do you say, over collect. And you can also specify the frequency of collection and any additional parameter. It's up to you because it's your infrastructure, and your analysis is completely customizable. So metrics collector, we have to make sure that metrics collector should be scalable to handle growing data volumes as the system expands with minimal impact on the performance system. If the metrics collectors or the metrics storage affects your system, they should be reduced because they're, what do you say, an appendix to the system. They're not a part of the actual infrastructure. We also have some of the tools. Um, as you can see, the tools are Prometheus, StatsD, and OpenTelemetry, which cater to different aspects of observability and monitoring. Prometheus excels in metric collection and query. It has its own query language, that is PromQL. And then there's StatsD, which is a lightweight and easy to integrate tool. And then we have open telemetry that specialize in distributed tracing or for comprehensive visibility into modern distributed architecture such as microservices, cloud native architecture, etc. The choice completely depends on the specific needs and goals of your observability strategy and your customized frequency and whatever your objectives are. The other variable in this calculation is metric storage. So metric storage refers to the repository or databases where collected metrics data is stored for later analysis, visualization, and long-term retention. So you see, these metrics are collected through metrics collectors, say tools. For example, we are using Prometheus, and it collects the data, and then it stores the data into repositories and databases, and then together it can be accessed by a visualization tool through which you can analyze those data into, like a very comprehensive scale or system. So it is easy for you, like as a developer or a layman, to understand what our containers or what our infrastructure is going through. So metric storage systems also need to scale horizontally to accommodate the growing amount of data generated by metric collectors. This ensures that they can handle the increased load. And the storage solution should support efficient querying and analysis for metrics data, so you can actually extract facts and actual information which will be useful for your organization or your team to increase the efficiency of your own architecture. Also, there's another thing that one should keep in mind, that metric storage should be compatible with visualization tools such as Grafana, Kibana, or custom dashboard, which is essential for user to interpret and derive insights from the stored metrics data. As we talk about that, if it's visualizable, it is, if you can see it, if it's on your screen, you can actually solve it. So also not to forget that these storage systems, or where you're storing your data, should be kept securely. So robust security measures, including access controls and encryption, should be in place to protect sensitive metrics data from unauthorized access. Now let's talk about RED metrics. The RED stands for rate, error, and duration. So this is a combination of metrics collection, or you can say a methodology. So these represent the three key metrics you want to monitor for each service in your architecture. The goal of RED method is to ensure that the software application functions properly for the end users above all else. In the modern era of microservice architectures, containers, and cloud infrastructure, metrics related to hardware aren't nearly as important. important as long as your service level objectives, or you can say SLOs, are being met. What are service level objectives? These are the objectives that you kept in your documentation, or you can say in the vision when you were creating this architecture, when you're creating your digital architecture. These are called the service level objectives. So the rate stands for the number of requests the service is handling per second. Then there's error. It is the number of failed requests per second, and duration, the amount of amount of time each request takes. So you can see here that these different aspects of red matrix deals with the positive, the negative, and the performance of the whole architecture. So it gives you a whole view when you're using it in your methodology. So you don't miss out on anything, and you have a robust visualization. So you can, step by step, because these things are the major setbacks when your architecture is crashed or is failed. So these three things can guide you what you have to um, improve or what you have to fix. Using these three metrics, these are some of the benefits of red metrics. Using these three metrics, you can get a solid understanding of how your services are performing, of course, because it tells you about the number of requests, the number of failed requests, and the amount of time each one takes. And the portion of those requests that are errors let you know if a service is functioning within your SLO. So the first benefit of the red method is helping to reduce the cognitive load required for engineers to determine why a service is having issues. Red abstracts away the internal details of each service into something that can be understood across the entire architecture. If we, in the next few minutes, we'll see how a dashboard looks like, and you'll understand that how easy it is to navigate through it. And you don't, with the modern tools, you don't even have to worry about creating the query. It is all given into tools, and you just have to navigate through it. So what it indicates, it means that problem can be solved faster, but also that it is easier to scale on operations team, because members can now be on call for services they didn't write themselves. And another benefit of red method is that it more closely aligns with the user and the company's overall objectives. Users don't really care about your infrastructure. They don't care about your CPU utilization, your memory usage, or any other hardware metrics. And most of the users don't even know about it. So they care if they start seeing error messages when they use your app. They care if pages on your website take a long time to load, or majorly users care about convenience and how catchy, or how fast your application is. So when you analyze these results, or you analyze these metrics, you understand that your application is not performing as well as you visioned or planned, or if it overperforming, or it is not being utilized well. So by these, you can scale it up, you can scale it down, you can increase the volume, you can take decisions on your own. And a final benefit of the red method is that automating tasks and alert across your services becomes easier. When you see the error rates, you can automate the tasks which are repetitive or getting errors because of human errors or human labor. So you can automate those, and you can also standardize things like a dashboard layout across services, because the same three metrics are being used. Now let's talk about the two. Um, so Grafana is an open source analytics and visualization platform that integrates with various data sources, including databases, monitoring tools, and the time series databases to create customizable and interactive dashboards. It is widely used for monitoring, observability, and analytic purposes, allowing users to visualize and analyze their data in real time. Now, this was the definition. Of course, we have to go through it, because you must know what this tool stands for. But now we'll go on to the demonstration, and we'll actually see how a dashboard looks like, how we can create our own, how we can actually create our own query, how we can set up our own dashboard. So let's get started. So this is a demo dashboard. Um, just a minute. Okay. So this is a demo dashboard itself from Grafana. This is a weather demo dashboard. And you can see how this particular dashboard is using quantitative measures to go through the results and check humidity, what is today's through. It can be, filtered by location. Let me see. Let me change this. Okay. So you can see the results, how much the humidity, UV index, precipitation. These are different filters. So these names and these all are created by different queries. And you can also see the location over here, and you can zoom in, zoom out. Yeah, you can also see the time layer, etc. So these are all the filters you can add in, and you can see how convenient it is to go through the whole temperature system. Now, when you create it for a infrastructure such as a digital architecture or cloud native architecture, you include things like memory utilization, error rates such as error rates per node, node performance, etc., CPU ratio, etc., to see how your infrastructure is performing. So that is the you can watch over your infrastructure as a service. So let's see and create one of our own dashboards. Yes. So this is the home to Grafana. You can you can also see this demo dashboard here, and I really like it because of its colors and how it's utilizing a dashboard which is usually used for softwares to display temperatures. So it is a pretty good idea. And yeah, we'll go on dashboards and recreate a new one. Yes, we'll go to add visualization. So you must keep in mind the word visualization. It will track you. It will help you track through the flow because what are the metrics? These are only data, right? And only after visualizing those or analyzing those in a complete manner, you'll get results. So let me okay. So as you can see, this data source. This is the metric. What do you say? Metric storage. Yeah. Some no sorry, metric collector, and I'm accessing Prometheus data, and where it is stored would be the metric storage. So I'm accessing that metric collector and storage from this, and I'll add a query. You can see here the query options. It is much like what do you say, a database query thing, but it is much more convenient, and it is designed to work with the cloud native architecture or any infrastructure, any digital infrastructure. So what do we can create? Okay, okay, we'll create something that is understandable. Okay, right. So we'll create a query or a panel for container CPU usage seconds total. That is the complete CPU usage seconds. And let me see the query. From here, you can also add some of the query options like aggregation and range functions, increase, summations, average, minimize, maximize, just like we do in a simple database or any other database tools. Okay, I don't know why. It's running my query right here. All right. Yeah. So you can see the graph here. It is like the default system, or you can, the default time series. So this is how you measure it. But you can also have other options. You have so many options to choose from. Let's take something else. This is statistics. Okay, this shows nothing. Okay. There are so many gauges. Okay. Oh, it's showing a lot of gauges here. Let's go to our time series because it's hard to understand. Yeah, this one is showing much more clear how what is the CPU uses seconds. Okay. Now let's take. I'll keep this one, and we'll create another panel for something else or some other series. Okay. Let's take the source, select a metric. So you can see this is a function that was created on through the tool itself. So you don't have to worry about the queries or if the syntax is right or anything. We create it for you. Hmm. Let me remove this. I need this one. Okay. Okay, this is something different. This is a bar chart. Let's apply this as well. You can also drag it through. So as you can see, it is pretty convenient to use it and read. Of course, if you know these terms, that is important. Okay, this is a rate metric. Okay, right. Okay, this is stat metric. I want something with gauge. All right, let's do this. Yeah. So if there's a system, or if you want it, you can reduce it. You can create your own one like this. So it's basically using a visual. It's pretty easy, and when you hover through it, you can also see the query. So this helps. Those people or developers who are not very thorough with reading or knowing about the metrics. So this was it. Let me try something else as well because I'm liking it and it's pretty convenient. So, right. Let's see what else we can use. All right. Let's see what this. Mhm. Okay. Nice. This is pretty good. Okay. Okay. This logarithmic function made it quite hard to read this one. As I'm going to remove this. You can make any combination. It's my dashboard, so it's up to me. So also, you can also explore this tool that is Grafana, and you can also try creating metrics for your own system. Other than this, you can also use our tool that's initialized with AI. Uh, it helps you know about the security and compliances of your application, and it reduces your effort for deployment. So you can visit our website as well. um, that was mostly all for today, and this was mostly about metrics in a nutshell. It's a huge topic, and if you have any doubt or any questions or any suggestions about our content, you can always feel free to drop it into the comments, or you can feel free to connect with me or to our community. So I hope you liked our session, and we'll be continuing this next Tuesday, and we'll learn about tracing. So that is the third pillar of observability. And if you like the content, you can like this video and also subscribe to our channel. Thank you for attending, and I'll see you next Tuesday.